In section 2, we'll be looking at data classification. We'll group data into different categories based on what type of data we're looking at. We'll look at how do we distinguish data from being qualitative versus quantitative. And then we'll look at different levels of measurement, whether data is nominal, ordinal, interval, or ratio. So we want to be able to, when we see data, recognize which of these categories does it fit into. So qualitative data, notice the root of the word qualitative is quality. Qualitative data consists of attributes, labels, or things that are non-numerical typically. They describe a quality. So if you look at what someone's eye color is, whether they have brown eyes or blue eyes or green eyes, etc., notice that those are categories. They're non-numeric values, so these are considered to be qualitative data. If you describe your place of birth, what state you were born in, or what city you were born in, those would be non-numeric. Or if you looked at what you were majoring in college, that is a non-numeric response. A lot of surveys deal with non-numeric responses. So these are qualitative data. Quantitative data, notice the root of the word quantitative is quantity. It's when our response is a number, an amount. When you're asked how old you are, your answer is an amount. How many years have you been alive? If you're asked for the temperature, you're expressing a numeric value to represent the heat level. So most of the things that we deal with in statistics, not all of them, but most of them are going to deal with quantitative data. We're going to be doing calculations, and normally when we deal with calculations, we're dealing with numeric values. So here's an example. This table relates the number of head injuries to the sport. By comparison, of course, probably as to be expected, there are more head injuries in football listed than any of these other categories. Gymnastics, yes, gymnastics does have head injuries sometimes. People fall the wrong way, etc. But we would expect way fewer head injuries in gymnastics than in football. So the question is, which of these data are qualitative and which are quantitative? So we have a category here. This is data. I might ask you, what sports have you played? You could give me any answer from this list, and those responses are non-numeric responses. So those are qualities, not quantities. For example, gymnastics and hockey, those are a type of sport. It's not a numeric response. But there are values that correspond to those that are numeric. The number of head injuries, that is a value, a numeric, a number, an amount. So those are quantitative values. Now, when we're looking at quantitative or qualitative, then depending on which one there are, we do have different levels of measurement. Nominal is probably the lowest level of measurement, or kind of our base layer, and it refers to only qualitative data, only quantities, only categories. It's going to be for non-numeric things typically. Sometimes you will see a number as a reference, but usually that number references a particular category. So when we look at the example earlier of hair or eye color, that was an example of a nominal level of measurement. There's no computation can be made as far as from the answers. They have the categories describe names, labels, and qualities, but when things are nominal, there's no sense of order. No sense of order. So if I list eye color as blue, brown, green, these are not in order from least to greatest or greatest to least. Order is not really significant here. Now, after we collect the data, we might put them in order based on which category has the most values in it. But if one person did a survey and they listed blue, then brown, then green, and another person did green, then brown, then blue, those are not increasing levels of significance. So if there's no level of significance from one to the other, those are nominal. No particular order matters. Oh, now I wrote over the top of it. Erase this. Things that are ordinal, order does matter. They can be both qualitative or quantitative. Things can be put in order or in a rank. But one thing that is important to note here is the difference between the entries is not meaningful. If we subtract one entry from another, find out how far apart they are, that's not significant. But there is a significance between which comes first, which comes second, which comes third, which comes fourth. So there is an importance on order. An example of this would, we'll talk about the slide in a second, but an example of this would be a level of satisfaction. If you give a survey and you ask, what is your satisfaction level? Are you very satisfied? Or are you satisfied? Are you dissatisfied? Or are you very dissatisfied? And usually there's like a neutral in the middle. Then notice those levels, there is an order to those, going from very satisfied to very dissatisfied. So something that is good or very good to something that is very bad. So the farther we progress through the scale, there is a significance between our levels. It's either increasingly bad or increasingly worse. The order does matter. So let's look at this slide. Let's look at this example. They want us to look at these two sets of data and determine which of these is nominal, which of these is ordinal. So the first one, if we look at the top 5 U.S. occupations with the most job growth, the first one is personal care aide, then registered nurses, then home health, combined food preparation and serving workers, and then retail salesperson. So these are the top 5. There is a ranking here. This is the top ranked. This is the lowest in the top 5. So the order does matter here. But if we compare that to the number 2, these list different movie genres. Action movies, adventure movies, comedies, drama, horror. Notice there's no we can mix those up. These appear to be in order alphabetically, but there's no level of significance. As we make our way down the list, we don't get increasingly bad, increasingly good. It's just a different type. These are not ranked. These are not ranked. And that's what this slide will go on to sell. For the first one, the data can be ordered. For the next one, there's no particular rank in those. Also, one thing I didn't mention about these is the difference in their ranks is not very meaningful. This number one is 2 levels higher than that one. It's 3 levels higher than that one. But if we do 3 minus 1 or 4 minus 1, those numbers are not hugely significant. These are just put in an order, but the difference between them just means how far apart they are. It's not a huge significance. All right, the next level we'll discuss is interval level of measurement. It's used for quantitative data. It's dealing with data that can be put in order. So it's similar to ordinal data, but the differences are meaningful. If we know how far apart 2 values are, that has very important meaning. If I know that at one point I weighed 135 pounds, at another point I weighed 175 pounds, the difference in that is meaningful. It means that I gained some weight, and it tells us how much weight we gained. We can quantify how much weight I've gained from this point to that point. Here, 0 represents a position, but it does not necessarily mean that there is none. So while talking about my weight, there is a difference that is meaningful. Weight is actually not an interval level of measurement. A good example of an interval level of measurement that has a 0 that does not imply none is temperature. If I compare 50 degrees Fahrenheit to 70 degrees Fahrenheit, there is a significance between the difference. We could somewhat quantify or understand what a change in 20 degrees Fahrenheit feels like, what that means. But if we look at 0 degrees Fahrenheit, this doesn't mean that we have no temperature. It doesn't mean that there is no heat in the atmosphere or in the environment. It simply is a comparison, comparing it to other temperatures. This temperature is 50 degrees less than 50 degrees Fahrenheit. On the Celsius scale, 0 degrees is the freezing point of water, but that is not the lowest temperature. Even Fahrenheit and Celsius both, there are negative temperatures. So obviously 0 degrees doesn't mean that there's no heat, because there are scenarios where you have colder temperatures. It's just a level of comparison. The differences are important, but when you get to 0, that doesn't mean there's no heat or there's nothing in existence for that value. It's just a reference point. The Celsius scale is based around the freezing and boiling temperatures of water. 0 degrees is where water freezes. 100 degrees is where water boils. So these are just reference points. On the other hand, ratio levels, they do have gaps that are important. The difference between one number and the next, that quantity does have significance. Unlike ordinal, the difference is important, but zero does imply none. This is essentially the only difference between interval and ratio is the fact of zero. So when we were talking about my weight, if I said something weighs 0 pounds, that means that it has no weight. Where if I say something is 0 degrees Celsius, that does not mean that it has no heat. It's just a reference point. This is a kind of confusing statement, but they say a ratio of values can be formed. I mean, we can take any two numbers and make a ratio, but for that ratio to be significant, we do have to have an inherent zero. That refers to none, and that gets really out there. So probably some of the examples will make a little bit more sense. Same thing here. One data value can be expressed as a multiple of another one. If I weighed 100 pounds at one age and then I weighed 200 pounds at another age, then it would make sense to say 200 pounds is twice 100. So that is a ratio value. But what would not make sense if I said one day it was 50 degrees Fahrenheit and in another location or on another day it was 100 degrees Fahrenheit. 100 degrees is not twice as hot. 100 degrees does not mean we have twice as much heat as we do when it's 50 degrees outside. So if multiples make sense, that's a ratio value. If multiples do not make sense, then that is not a ratio value. That's just an interval value. So here we have some different data. The one on the left are different years that the Yankees won the World Series. The one on the right is the home run totals for each team in 2016. So let's begin by looking at the years that the Yankees won the World Series. Those are intervals. Yes, there's a significance between 1923 and 1953. That is 30 years later. We can get a difference between years, and that makes sense. But there's real no significance of zero. If we say zero, yeah, that's zero at some point, but also in our way of keeping up with years, that's just AD. There are years before that. There are prior years to the year zero. Also, a ratio would not make sense. If we took the year 2000 and divided by the year 1923 or so forth, what does that ratio even mean? But if we look at the data on the right, no team has this, but we understand what zero means. Zero means that a team would have had no home runs. And ratios also make sense. If no team has this, but just for simplicity of numbers, Minnesota had 200 home runs. If another team had 100 home runs, if we made that as a ratio, it would make sense to say that Minnesota had twice as many home runs as a team that only has 100. So a ratio does have some kind of sense of value in these numbers, where a ratio over here doesn't really pose any level of significance. So here's just a chart that kind of summarizes these. All of these, in a sense, can put numbers into categories. Even things that are quantitative, if I say I have 5 cookies or 6 cookies or 7 cookies, those are quantities, but we can think of those as categories of how much I have. A person that has 7 cookies categorically has more cookies than a person that only has 5. Things that can be arranged in order, well, things that are nominal cannot be arranged in any kind of order. What things can we subtract the values and there be some kind of sense? Well, just interval and ratio makes sense if we subtract the values. Determine if one data value is a multiplier of another. Well, multipliers and ratios only make sense for values that are ratio values. So just a couple more examples. We look at types of TV shows on a particular thing. Those are qualities. There's no particular order if we're just listing what the categories are. So qualitative values at the nominal level. If we look at ratings for movies, these are categories. So these are qualitative. And notice as we work our way through these different ratings, order does matter. Just ask parents when they choose to send their child to a G movie versus an R movie. Yeah, there is some progressive level here. The further we get down the scale, the more violent or the more language or the rougher the content is in the movies. So these are increasing order of maybe ages that should be permitted to see these type of movies. Here we have average monthly temperatures for different months. So these are quantities, these are amounts. But pretty much anything dealing with temperature, the numbers are significant, and the difference between the numbers are significant. Here there's roughly a 2 degrees difference, where here there's a 27-degree difference. That is something you can noticeably feel, but there's no zero level here. No zero level here. Where if we looked at the levels of rain, yeah, there's a difference. Here there's only 3/100ths of an inch different, where here there's over an inch difference. So the difference between the values is important. Also, a zero level would make sense. If 1 month had an average precipitation of 0, that would mean that in no day did it rain. It was completely dry that year. And a ratio would make sense. September is roughly 3 times or 2.5 times the rain level from January. So there's a significance. This is a multiplier of another year. So that's what section 2 deals with, just categorizing data into different groups. And it helps us to kind of have a better grasp of, as we're talking about data, what kind of things do numbers make sense with, and what numbers are significant.